Natalie and Stephanie are selling flower bulbs for a school fundraiser. Customers can buy bags of windflower bulbs and packages of crocus bulbs. Natalie sold 3 bags of windflower bulbs and 18 bags of crocus bulbs for a total of $378. Stephanie sold 6 bags of windflower bulbs and 5 packages of crocus bulbs for a total of $198. The table is completely optional. It just helps me to organize all of the information we're given in one place. So the most important question here is what this is asking. It's the cost of 1 bag of windflower bulbs and the cost of 1 package of crocus bulbs. That question is important because it tells you what your 2 variables need to be, and you have to define your variables. So I'm going to make X the cost of 1 package or 1 bag of windflower bulbs. That means Y is going to be the cost of 1 package crocus bulbs. Okay, the goal here is to create a system of equations, and with 2 variables, that means we need 2 equations so that we can solve for both unknowns. And we've made windflowers go with X and crocus bulbs go with Y. So I'm going to go ahead and just go X and Y on these. Now I've got 2 equations. You can solve these using any method you'd like. However, just glancing at this, I would think if you take that first equation and multiply everything by -2, elimination is going to be the easiest way to go. So if we go ahead and multiply here, I now have -6x minus 36y equal to -756. So now I can focus on just these 2 equations and add. These will cancel out. I get -31y equal to -558. So if I divide, I get that y is 18. And I want to label that with dollars. And I've already assigned y to be the cost of a package of crocus bulbs, so you don't need to label that again as long as you've defined your variable. Okay, to find x, you just take the y value and plug it back in. I'm choosing the top equation. You can pick either one. So I've got 3x plus 18 times y, which we now know is 18, equal to 378. Just simplifying. And then subtract. So x is also going to be 18, and we want to label that with dollars so we know what the unit is. Then you're done. All right, this time we have Maria and Bill that are selling cookie dough for a school fundraiser. They are selling both sugar cookies and gingerbread cookies, well, the cookie dough. So it says Maria sold 9 packages of sugar cookies and 13 packages of gingerbread for a total of $166. Bill sold 8 packages of sugar cookies, 13 packages of gingerbread for a total of $162. So what is the cost of 1 package of sugar cookies and 1 package of gingerbread? So this is kind of our essential question here. That's going to help you define your variables. So I'm going to make x be the cost of 1 package of sugar cookies and I'll make y be the cost of 1 package gingerbread cookies. And again, now we have a system of equations, and you're wanting to solve them. Any method will work, but I'm seeing we've got 13y involved in both equations. So if I multiply this top equation by -1, I now have -9x minus 13y equal to negative 166. And I'm just going to copy that bottom equation as is. Now we can add. So I end up with a negative x equal to negative 4, which leaves us with x being $4. Whew, let me try that again. And again, we've already labeled what x is, so we just need a unit involved. Now to find y, you take the value of 4 for x and plug it back into one of the original equations. I'm going to pick the top one. You can pick whichever one you'd like. So simplifying and subtract. So we get that y is $10. Okay, the next type of problem we have has to do with two different solutions being mixed together. And I'm a visual person, so I'm going to kind of set this up. We've got some solution plus another solution equal to a total solution. If you're artistic, feel free to draw beakers or whatever you want. And the other thing that we have here is we have different amounts. So I'm going to put little blanks for the amounts. All right, so let's fill in what we've got. So we want to know how many quarts of a 65% sugar solution, that's what we're looking for. How many quarts of a 65% sugar solution must be mixed with 5 quarts of a 5% sugar solution to make a 45% solution. So this is the goal, a 45% solution. We're combining a 65% and a 5%. Okay, and if we remember back here this essential question, how many quarts of a 65% sugar solution, that's going to be your x, or your variable. So we want quarts of 65% sugar solution. All right, so we'll put an x because we don't know that amount. We know there are 5 quarts of the 5%. Now here's where you have to use a little bit of logic. You're mixing together x plus 5. So this x amount plus 5. So that means our total amount is going to be x plus 5 quarts. So we want to just turn this into an equation. So instead of writing 65% like a percentage, I'm going to write that like a decimal. So I've got 0.65x plus, I now have 5 times 0.05 equal to, I'm going to go ahead and move that 45% to the front. Now you've got your equation. And if you can go straight to that equation, that's fantastic. Again, I'm a visual person, so I need the extra organization there. So if I simplify, fabulous. Okay, so I'm going to subtract the 0.45x, which gives me a 0.2x, and I'm going to subtract the 0.25, which gives me just 2, and then divide by 0.2, so I get 10 quarts as my answer. Similar problem, we've got 2 different solutions that we're mixing together, so I'm going to use kind of my visual here to help me organize things. So Heather wants to make 15 gallons of a 32% sugar solution. So wants to make, that would be the end goal. So we want 15 gallons of a 32% solution. By mixing together a 30% sugar solution and a 40% sugar solution. The essential question is how much of each solution should she use? So we're looking for 2 different amounts. which your initial thought might be create two different variables, but you only have one equation. So I would suggest using one variable, and then we'll kind of use logic to come up with the second answer. So I'm going to assign X to be gallons of 30% solution. If you want to write sugar solution, that's probably the most specific. So I'm going to say we have X amount of 30%. Now we want the total to be 15 gallons. And if we already know that the 30% solution comprises X amount, how could you come up with this value? So what I would do, I would take your total and subtract what you already have. Now you're set to make an equation. All right, so simplifying, I'm going to distribute. All right, and combining like terms over here, I end up with negative 0.1x. I'm going to go ahead and subtract 6. And then divide by negative 0.1. So we end up with 12 gallons of the 30% solution. That's one answer. Okay, now to figure out how many gallons of the 40% solution, you have to look at your total amount again. So we want a total of 15 gallons, so we already have 12. This must be 3.